So what I'm having everybody do is I had our students flip, guys, each individual person took a Hershey Kiss and flipped it 50 times. And we're trying to find the true proportion of points ups, so how they land. And so each person, each student flipped their own Hershey Kiss 50 times, and we're going to create their own personal confidence interval. And then we're going to graph them all on the same scale. It looks very similar to something like this, where I had a scale from 0 to 1, and then we had several confidence intervals. I'm just kind of drawing a little estimate here, something along these lines. Okay? Now, what I'm asking my students to kind of look at now is to look at the graphs. You can kind of see them from afar. And when I'm looking at these confidence intervals, how can I answer the question, what is the true proportion of Hershey Kisses that will land point up? So what do you think? Looking at the green paper, not on the smart board, but the green paper off to the side, how could I answer that question based on the confidence intervals we created? What level of confidence did we use? 99%. So whatever estimate that we come up with, we're going to be 99% sure. What am I looking for in terms of these numbers? Where they all overlap. Okay? So in other words, I'm just going to kind of really quickly, if I was to draw a vertical line somewhere about here, that doesn't quite catch it. If I went ahead and moved it to the right just a little bit, still doesn't, sorry. Hang on. I'm a little off. Most of them caught. The only one that didn't, this guy over here, was outside of it. Would you agree? And that's just kind of I just drew it up there as a sketch. But I'm looking for where a place where most of the confidence intervals will overlap. So I'm going to take a yellow piece of paper here, or whatever, string, and I'm going to ask Josh to kind of hold it up from the top for me if you don't mind. Just hold that up there. And we're going to you guys decide. And you guys are kind of close. Should I move it to the right or to the left a little bit to capture most of them? A little bit to the right? About right there, would you agree? Look, and this one has caught each one. So I'm going to go right about there. Thank you, sweetheart. Okay. Do you agree that that vertical line that I've drawn has captured all of them? Okay. What number or what proportion is associated with that value? About 35%, 0.35, approximately. Okay. And if you actually look at block 2's, their scale was a little bit more accurate. I had to do mine quickly, but here it was right between 0.3 and 0.4. Do you agree? Okay. And we estimate it to be about 33%. Do you feel confident in saying that that is the true proportion of Hershey Kisses that should land up, point up? Actually, if you think from a geometric point of view, it makes sense. From a geometric point of view, what's the volume of a cone? I'm assuming that these Hershey Kisses are approximately cones, right? Estimate. You remember from geometry, it's 1/3 pi r squared h. Geometry, folks. Remember that? And what's the volume of a prism, or of a cylinder? It's pi r squared h. So isn't a cone 1/3 of the whole cylinder? So doesn't it make sense that the probability that it's going to land up is 1/3, approximately? Approximately, right? So it's kind of like this estimate. So do you feel pretty confident that we have captured the true proportion here? The more confident, the more intervals we create, if we did 99 of them, if we did 100 of them, wouldn't 99 of them capture it, and one would be left out? The likelihood that would happen. Okay, good. So what I want us to do is I want us to look at our homework now. So I go ahead and looked at it, graded it, gave it back to you. I definitely want to do the last problem, number 27, because a lot of us just kind of wrote the answers without giving a lot of work to 27. I graded number 14, but what homework problems would you guys like to go over? Here's your chance. So I know I'm going to do 29. But would you like to do 14 and 29? That's no problem. So we'll start with 14, okay? So let's look at question 14 first. It says that we have a random sample of 799 teens. So that's our sample size. And they're sampled about internet use. It does say that 49% of those teens, so of our sample, so that's our p hat, reported that they had misrepresented their age online to gain access to websites and online services. It says to find the margin of error if we want a 95% confidence in our estimate of the percent of American teens. So we want 95% confidence, and we want to find the margin of error. How do I find the margin of error? What is the margin of error? What do I do? What's the margin of error? Don't give me a number, just in general terms. What's the margin of error? If I go back to the formula that we did up here, and we're looking strictly at this, what's the margin of error? The intercept. So here's our p hat. It's what's on either side of p hat. So it's this information. Would you agree? If you think about the picture, what we've drawn up on the board on the green paper, it's what's on either side of our sticker. Do you agree? Okay. So we're looking at z star times p hat q hat. So z star times the square root of p hat q hat over n. That's our margin of error. Do I have z star? How do I find z star? If you memorize it and you know that it goes with a 95% confidence interval, it's 1.96. Okay. Do I have p hat? 0.49. What's q hat? 0.51. Good. And then our sample size was 799. So go ahead and plug that into your calculator. Tell me what you get. I expect to see this work. Okay. So I'm looking for that calculation to happen. I got 0.035. At least that's what the book got. Did you guys get that as well? Okay, good. So that's part A. Part B says, explain what margin of error means. What is it? Angelica read the definition. Read it again for us real quick. Okay, the interval on either side of p hat. Give me something else besides what she just said. Okay, that's the formula. I agree. Give me something else about the margin of error. What is it? Related to part of the interval. Give me some more. Yes. Give me something else, Cameron. Okay, it has to do with the interval and the range. Is it the entire width of the interval? Is the margin error from, if you're looking over, I'm sorry, if you're looking at our green piece of paper over here, is the margin of error from end to end? Is it the width of that whole thing? No, what is it? Not any point within. Specifically, the margin of error is what I add on either side. So what's, in terms of the width of the interval, what's the margin of error? It's half. Would you agree? Because the whole interval is this length. The margin of error is just what you did on either side. So it's just half of the width of the interval. Okay? All of those answers would be acceptable. Okay? Part C says, if we only needed to be 90% confident, will the margin of error be larger or smaller? So if I'm changing my level of confidence now, I'm no longer 95, so this number is going to change. What would 90% be associated with? So this would become 1.645. Do you agree? What happens to the width of my interval? I'm less confident, therefore my interval now does, it narrows. It becomes smaller. Okay. So let's find it. What is that margin of error? Go ahead and plug it back in. Tell me what you get for D. I got that. That's what I graded for extra credit, by the way. Huh? You put 0.030? Okay, let me look. right. So part E is interesting. It says, in general, if all other aspects stayed the same, the confidence level stayed the same, P hat, Q hat stayed the same, but the only thing that changed was the sample size. So in other words, this number down here, the 799, is the one thing that changes. Is the margin of error going to get bigger or smaller? Let's say, for giggles, that we changed n to be 1,000. Can you go ahead and find out what the new margin of error would be? Take a second, plug it into your calculator. And I want you to tell me what happens to the margin of error when I increase my sample size. So, Maddie, go ahead and plug it in. I'm going to pause my recording. Byron, I want to see you doing it too. It's about, so if you did this, you got about 0.026 approximately. Is that right? Okay. So what happened to the margin of error? It was 0.029. I increased my sample size, and what happened to my margin of error? It went down. Why does that make sense? When I divide by a larger number, don't I get a smaller number at the end? So as I am increasing my sample size, my margin of error should also decrease. So what are the two things, if I want to shrink, I guess it's a way to say it, shrink my confidence interval, I want to make it smaller. What are the two things that we know of that will do that? The one thing we just said was increase the sample size. I would write this down if I were you. You'll probably see this again. So if we increase the sample size, our margin of error will get more narrow. What else will make the confidence interval more narrow? Something to do with the confidence level. Am I going to increase my confidence, or am I going to decrease my confidence to make my interval more narrow? Decrease it. The less confident I am, the more narrow it's going to be. Okay? So those are the two things that you can do to manipulate, because really the goal is to capture the true parameter, right? We want to figure out what is the true proportion of Hershey Kisses that are going to land face up or point up. So the smaller interval we get is better. The wider we get, I mean, what is that really telling us? So the ultimate goal is to get the most narrow interval that we can. Okay? Any more questions about chapter number 14? Okay, let's look at 27. 27 I thought was kind of tough, but only because we hadn't thoroughly talked it out in class, but we will now. I'm sorry, 29, not 27. 29. So it's talking about graduation. It says it's believed that as many as 25% of adults over 50 never graduated from high school. Wow. Over 50. I guess that's true. It seems kind of high to me, but who knows. Let's keep reading. It says, I continue, we wish to see if the percentage is the same among the 25 to 30 age group. Okay. Would you think it would be the same? Just kind of historically in your own experience, do you think that 25%, you think it's higher? People that did not go to high school? Right, it's the other way around, don't you think? So this is the percent of people that did not go to high school, or graduate from high school, I should say. Wouldn't you think that it'd be a little bit lower now? More people go to high school and graduate now than they did when your parents or grandparents were around, right? Neither of my grandparents graduated from high school. One got his GED, the other one dropped out in 8th grade to become a potato farmer. So just what happened. But as we've become more industrialized and as things have gone on, more people go to college. Or college, high school, graduate. So it says here in part A, how many of this younger age group? So I'm going to stop right there. How many? What am I solving for? Am I making a confidence interval? No. What does how many What am I solving for when I answer that question? Which letter in the formula? P, Q, N, Z, N. How many means what sample size am I looking for? Okay? So it says, how many of this younger age group must we survey? So how many people am I asking? In order to estimate the proportion of non-grads to within 6% with a 90% confidence. So let's make sure we understand all the information, okay? 0.25, that was the claim, 25% of people over 50, okay? How many of the people that do we need to ask in our sample? So we're looking for N. What does within 6% mean? Talking about confidence intervals, so what does within 6% mean? Yeah, 0.06. So within 6% does refer to the margin of error, okay? And so the margin of error, we want it to be within 6, so less than or equal to 0.06. Would you agree with that? Okay, all right. 90% confidence, what information does that tell us we need to use? For which value? So Z star. So our Z star is going to be 1.645. Okay, that's a Z star that's associated with 90% confidence. So let's see. I have a margin of error. So let's use our margin of error formula. Remember, our margin of error formula is Z star times P hat Q hat over N. I don't know P hat Q hat, but I know the claim. Can I just use P and Q? So that's what I'll use instead, okay? So let's do that. Let's plug in what we know. Do I know the margin of error I want to use? 0.06. I want it to be within, so I'm going to make sure that it's less than or equal to that, right? Any questions as to why I'm using less than or equal to, or in this case, greater than or equal to? The direction of the inequality. Okay, so we want the margin of error to be less than 0.06, because within 6% means 6% or less than that. So the formula for margin, I just kind of wrote them on the opposite sides. But so since the 0.06 was on the right, it opened up to the right. Over here, it opens up to the 0.06. Okay? Z star is 1.645. Let's plug in what we know. 0.25, what's Q? 0.75, good, April. And I'm solving for N. Okay? This is algebra 2. This and only this, believe it or not, is the only reason why you need to have algebra 2 to come to this class. This one little formula. Okay? So how do I solve for N? Let's figure out where N is. N is down here. Do you remember when you have a radical back from algebra 2, how do I solve for where this is? What do I need to do? What do I have to get rid of? Not yet. There's actually 3 things I need to do. I hear something about the square root. I got to get rid of the square root. I can't do that yet. What do I have to get rid of first before I can get rid of the square root? The Z star, the 1.645. Anytime you have a radical equation, you have to isolate that radical. Get it by itself. The 1.645 is with it right now. I've got to get rid of it. Divide it. Good. So I'm going to divide both sides by 1.645. It is essential that you do not round here. Okay? So everybody should get their calculators out. I want everybody to try this because it's not as easy or it's not as necessarily straightforward as you might think. Okay? So 0.06 divided by 1.645. So let's do that here. Maybe. Oh, because it thinks I'm writing. Awesome. Delete. There we go. 1.645 divided by, oh, other way around. 0.06 divided by 1.645. I do not want you to round that number. I want you to leave it in your calculator. If you round early on, it will affect your answers later on, okay? So leave it stored in your calculator. I'm going to write 0.036 on here just to show my steps, but I'm actually going to use the exact value in my calculator, okay? So 0.036 is greater than or equal to, and then what was left, what is 0.25, what was it, times 0.75? What's my numerator here? What's 0.25 times 0.75? Thank you. Okay, so now I'm looking at what's in my box. How do I continue the process to solve for n? At this point, Byron's right. At this point, I can square both sides because I've got my radical by itself. Do you agree? And when I do that, now remember when you did that back in Algebra 2, it could introduce extraneous solutions, and we had to check our answers because the square of a negative becomes a positive. Are we worried about negatives underneath the square root at all? Are we worried about that in this real-life application? No. Leave that mess back in Algebra 2. We don't care about extraneous right here, okay? Because it's not going to happen. We're going to be fine. So we're going to square both sides. Remember what I'm going to do. I'm not going to square 0.036, but I'm going to square the exact value. So if you just hit squared here, it'll square the previous answer without rounding, and we get this value here, 0.0013. And again, leave it in your calculator. Do not round it. So 0.0013 greater than or equal to, and then we have this still in my, after I get rid of the square root. Okay? Showing steps here. So what's left in blue is what we have. Still don't have n isolated, still don't have it by itself. At this point, what do I need to do? Multiply by n. Okay, we're trying to get it out of the denominator, so we'll multiply by n. Cancels over here. I want to get n by itself, so I have to also divide by 0.0013. So n is greater than or equal to 0.1875, which is an exact number, was not rounded, divided by 0.0013. So that's what we'll do here, maybe. So I'm going to say 0.1875, helps if I can type it in, 1875, divided by, now I want to go up and capture the exact value, so I'm just going to arrow up and capture it, so I'm not rounding it at all. And I hit enter, and I get 140.9. Okay, so n is greater than or equal to 140.9. Okay? There's a problem with leaving my answer that way. I cannot leave it that way. Tell me why. Why doesn't that answer make sense? What is n again? Just in general terms, what's n? The sample size. And in this context, it's people we're asking a question to, right? So can we ask a question to 0.9 of a person? No. It has to be greater than that. Would you agree? So at minimum, how many people do I need to ask to see whether or not they went to high school or graduated? 141. So 141 is the minimum sample size. Okay? I actually don't care that that was 0.9. We're not rounding it to 141 because it's closer because of the 0.9. Even if this was 140.2, I would still round up to the next whole number. Okay? Anything over 140, anything, we would take the next whole person. Okay? So just make sure you realize that. I want you to try B on your own. I'm going to pause the recording. Same kind of idea here. See if you can't answer it. So for question B on 29, it says, suppose we want to reduce the margin of error to 3%. So we want a margin of error of 3%. okay? It was, I think, what, 6% before? Within 6? Now we want to be within 3. Everything else stays the same. Tell me what my new sample size should be. Do we think it should go up or do we think it should go down? Let's go back to what we wrote here. If I increase my sample size, my confidence interval will be smaller, which means my margin of error will be smaller. I want the smaller margin of error. I'm going from 6% to 3%. So what's going to happen to my sample size? It should go up. So in part B, the sample size should be larger than 141. Try it. Tell me if it is. So we can't leave our answer this way. So what is the minimum sample size we would have to have? Okay, I don't think that's correct, but let me see what you did. Sorry, this was C, not B. This is the answer to B, by the way, but C, the answer was 500 and something. 5 what? 563 point what? 75. And it doesn't matter what that number is. I think even at the previous one in part B, it was 0.112, you still go up to the next whole number, okay? So 564 would be the minimum sample size in part C. My bad. Good. Thank you, Boris. I appreciate that. Do you feel a little bit better about your homework now? Okay. Notice all the work I was looking for in problem 29, that most of you just copied the answers in the back rather than actually show me the work. Okay? I guarantee you on your next quiz or test that this kind of problem will be on there, where you'll have to solve for a sample size. And you'll have to actually show me work. Okay? So make sure you understand how to do it algebraically. We feel comfortable. Good? If you're not, come see me. We'll talk about it. Okay? All right, you can go ahead and put your homework away. We're going to look a little bit more at confidence intervals, but in a different way. We're going to estimate the percentage of Earth that's covered by water. Okay? And we're going to create an interval to try to capture that true proportion of water. Now, I have a little inflatable globe here, and it's probably not as accurate as one might think, but it's not too bad. It was made in 2008, so it's a little old, but it's fine. What kinds of things, just not mathematically, but just in general, might affect the actual percentage of water that's on Earth? Just think about, like, in real life examples. What would make it go up or make it go down, or talk to me about it. Okay, so the global warming means that what's happening? So the North Pole is going away, the glaciers are melting, which would increase the amount of water, right? Okay, give me something else that might go the other direction. What might it decrease it? Tides actually doesn't affect the amount of water, it's just where it is. It's still on Earth, right? Drought, talk to me more about drought. What do you mean? Evaporation. Would you agree that evaporation takes water out of the ocean? So I agree. There could be more water in the clouds at one time as opposed to actually in the water. Yeah? Talk to me more about seasons. What do you mean? Okay. So El Nino, La Nina, those kind of things where we can become rainy versus snowy versus dry, all of those things. It's just a matter of where the water is, right? There's a finite amount of water around Earth, whether it's in the atmosphere, whether it's on the globe, etc. So I'm talking about oceans at this point is where I'm getting at. Okay? So I need for everybody to make a little X with a pen on one of your fingers. So let's all decide which finger we want it to be. I'd like it to be on your right hand, your thumb or your pointer, I don't care. Thumb, right thumb. Please make a small X with your right thumb. Somewhere where you can see. Little pen could be a little pinpoint, little dot, whatever. Or if you just want to say whatever. We're going to play pass the ball, and we're going to play catch. I do need us to spread out, so those of us that are clustered, please go in the back of the room. Byron, do you mind going to the back table? April and Noel, would you guys mind going to the back table? Ayana, come on over here. I just don't want anybody to get bopped in the face. Okay? It is an inflatable ball. No one will get hurt. But what we're going to do is I'm just going to pause the recording while we collect our data. And we're just going to catch the ball, and you're literally going to tell me where your thumb lands on the globe. Is it on land or is it on water? Okay, that's it. How many catches, how big of a sample size do we need to get? One of y'all could, Maddie, you could sit up here if you wanted. I guess, Josh, you're on your own. Good luck. You got good hands. You'll be all right. All right? How many catch, Maria, would you come up here, poor thing? Thank you. All right. How many catches do we need to have? What's our sample size need to be? Well, there's only like 18 of us in the class today. You think 18 is a big enough sample size? I think it's got to be more than that. I'm asking you, why does sample size matter? When we talked about with our Hershey Kisses, we did a sample size of 50. Was that big enough? What kind of conditions are we looking to meet? What's the conditions for proportions? No, what's the conditions? Random? 10%, and? What's the success failure? N times P is greater than or equal to, and N times Q is greater than or equal to. Okay? What's P? What's the claim? Anyone take environmental systems? What's the percent of water that's covered by, what's the percent of earth that's covered by water? About 70%. Okay? So we'll say that's the claim. Okay? 70%. So 0.7, not sure why the dot won't go there, but whatever. We're going to try it again. Okay, that was really strange. I need to solve for n. So what's 10 divided by 0.7? Y'all have calculators. What's 10 divided by 0.7? So 14.3. So we at least need 14 or 15 catches. How about Q? What's Q? Which is 0.3. What's 10 divided by 0.3? 33.3 repeated. So we need to have at least 34 catches. Can we just make 50? Is that okay? All right, so I just want to make sure you know how big of a sample size do I need. It's got to meet the conditions, okay? So we'll say at least 50. So girls that just came in from the field trip, make a small mark on your right thumb with an ink pen, and we're going to play catch, and you're going to tell me where that thumb lands or where that point lands on the globe. You're going to be kind and gentle. Do not throw at people hard in their face. Kika Grimes Bowles, you know who you are. Okay? She totally smacked someone in the face during block 2. Don't do it. Okay? Make sure there's no drinks or water so nothing gets thrown on the ground. And I'm going to pause the recording, and we're just going to collect some data. Okay? So here's the real-life data that we collected. What I'd like to do is to create a 99% confidence interval based on our data. So tell me what we need to find. N. P hat. What is P hat? What's N? How many times did I throw the ball? 50. I think 10, 20, 30, 40, 50 I did. So N is 50. What's P hat? Well, it's over 50. Would you agree? What am I looking for? 30. The amount of, so isn't it 35? 35 out of 50, right? So I don't know what that number is. What is that? Is it exactly 0.7? That's crazy. That's creepy almost. Okay? But let's create a confidence interval, okay, based on that, and let's decide whether or not we're going to capture the truth. Well, we know we probably did, but we'll go to Google Earth and see at this particular moment, is it really 70? I mean, I've seen it where it's 66.6, so maybe it's that. Well, we don't know. All right? So we'll Google it in a minute. We'll go to Google Earth, and they can give you an estimate at any given time. So what else do I need to do to create the confidence interval? I know the confidence interval formula. Okay, Q hat's going to be 15 over 50. And then what's Z star? 99 is not Z star, but it tells us how to find Z star. Do you remember how to find it when it's a weird number? So if we have the middle 99% And we have 0.005 on either tail. So the Z star is inverse norm 0.995. And it's a Z, so we're going to have 0 and 1 there. So what do you get? 2 point. Okay, so that's our Z star. So let's do it. So I have 0.7 plus or minus 2.576 times 0.7, 0.3. Is that right? Is that right? Okay. I'm just making sure I didn't do something wrong. So tell me what that confidence interval is. If you are okay with it, as long as you show me where the numbers came from, the 0.7 is your p hat, you told me what your Z star was, you plugged in the p hat, q hat, and n into my confidence interval formula, I am okay with you just going and finding the interval on your calculator. Remind me how to do that. Matthew? And what option am I looking for? Okay. One proportion Z interval, which is option A. What's x in this case? 35. It's the numerator of your p hat. So it's 35 out of 50. And the confidence level we picked was 99%. And we'll go ahead and calculate it. Okay? So we're really confident. So what kind of an interval do we expect? Pretty wide, would you agree? The less confident we are, the more narrow it will be. But here's our confidence interval. Can you interpret it for me? What does it mean? When I say interpret it, I want a sentence. So what kind of a sentence am I looking at? So we should write it. You should be writing it too. We are 99% confident that, be careful with not just the proportion, but the true proportion of. Now we're going to put our context, right? Proportion of water on Earth is between 0.53307, let's write percent since we're doing context, between 53.3% and 86.7%. Okay? That's going to be the interpretation of the interval. Sometimes the questions are written this way. They might say something to the effect of, the claim from my oceanography teacher or my systems teacher is that 70% of the Earth is covered by water. Do we have statistical evidence to support that claim? Yes or no? And why? Why or why not? We just did statistics, right? We just did some math. What does it mean is the point of my question, okay? Huh? Well, I'm not guessing. The claim is 70%. So from here on out, we're going to be testing against a claim, okay? And honestly, from now to the rest of the year. This is inference, and then we're trying to say, so we say that, well, actually, let's just Google it. Let's see what Google Earth says. Let's not estimate it to be 70. Let's actually do that. So do we have statistical evidence to support USGS's claim of 71%? Yes or no, and why? Cameron? Because what? It's exactly what you need to say. Okay? And that's what you were going to write. You're going to actually write a sentence to answer that question. If you're asking using a confidence interval, you are looking to see whether or not the claim is within my interval. Okay? So if the USGS claims 71% of the Earth is covered by water, according to what we just Googled, okay, because 0.71 is contained within my interval, we have evidence to, I'm going to put a blank there. You're either going to support the claim or not support the claim. Okay, and we say that because it's in my interval, I do what? I support it. However, we typically don't say that we support. Is anybody taking IB Bio or, all right, so you know how you never reject the null or fail, all that stuff with the testing, right? So we have the claim. You're either going to reject the claim, which says they're wrong. If we rejected the claim, where would 71% be? Outside my interval. Because it's inside the interval, we don't reject the claim, but we say this: we failed to reject the claim. I get that it's semantics, okay? But the wording matters. AP is very particular about the wording here. Very particular. If you say you accept it, that they are right, you will get points deducted. Because in statistics, nothing is ever 100%, right? We can never say it's always true. We can say we have evidence to support that it might be, maybe, could be true, okay? So we have to be very careful about our wording. So you're either going to reject or fail to reject. And in our case, because 0.71 was inside of our interval, we're not going to reject it. We have evidence to say that they're probably right, okay? Confidence intervals are great. They give us a range of values. We can kind of come up with some actual information here. But often it's not enough, okay? And often we need more concrete support. We need more convincing evidence. And what we're going to be doing next class is really emphasizing and talking about that, okay? It's a 5-step process called hypothesis testing. I don't want you to worry about it right now. We're going to get into it next class. But it's what we're going to be doing for most of the rest of the year, okay? So we'll get a heads up on that starting on Monday. Your homework, we're going to spend the last 20 minutes of class working on our quiz, and so Josh is going to go out, and Anna, I got to talk to you about yours. I'm going to hand your quizzes back to you, and we'll talk about what you're going to do about that in just a second. But your homework tonight, in addition to what I'm about to give you with the quiz, is going to be to read the next chapter, which is chapter 19. Doing the just checking would be a good idea, but I'm not going to be collecting it. I'm going to ask you to outline the chapter, just like you did before. It does reference hypothesis testing. So I want you to talk about things to think about when you're reading the chapter. What is a one-tailed test versus a two-tailed test? What's a p-value? What's the null hypothesis? Just some keywords I want you to be thinking about as you're reading through the chapter, okay? You should definitely be able to define those things specifically. All right, I'm going to go ahead and stop the recording at this time. We're going to talk specifically about your quizzes in just a second.